So continuing with our normal distribution examples, we have that cholesterol levels in men aged 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. So for problem A, what I want to know is what is the percentile for a 20-year-old man with a cholesterol level of 190. So I have a normal distribution and I have a mean of 178, and I want to know what percentile would a cholesterol level of 190 give you. So remember when I look up a z-table score, it finds the area to the left, and that works in this case, right? Because I want to know what percentile, meaning what percent of data values are below this. So for this, I need to calculate a z-score or a standard score, which is my sample data value that I want, minus my mean over our standard deviation. So in this case, I have 190 minus 178 over 41. That gives me 12 over 41, which is 0.29, right? Now that's not the area under this curve, right? Remember the area under the total curve is 1, because 190 is above the mean, it's going to be above 0.5. But what I need to do is I need to take this z-score and go to a z-table. So I go to a z-table and I find 0.2 and 9, and I go to where those intersect, which is right here. So I get 0.6148. That means the area to the left of 190 is 0.6148. So that means that that's got 61.41% of data. So I could say that the percentile is the 61st percentile if we round a little bit. Okay, now we're working a little bit backwards. So it's saying what cholesterol level corresponds to the 90th percentile. So that's the level at which treatment may be necessary. So I want to know what score would mark the 90th percentile. So what score has an area of 0.90? So for this, we're going to have to use backwards. This is my z-table value. My z-table value, right, comes from the table. And then that'll, if I work backwards, will give me a z-score, and I can solve for x. So let's go to our z-table and find 0.90. So I'm going to zoom in a little bit and look for something. Well, this is pretty close, but not quite. This is close. This is closer, right? This is the closest number. You can't really see it because I drew all over it. Let me try that again. This right here, right? That's the closest one, that 0.8997. So that's the z-table value. I want to see what z-score corresponds to it. So that's going to be 1.2.8. So 1.28, that's going to be my z-score. So let's zoom back out and go back. So I have 1.28 is some unknown data value minus our mean over our standard deviation. And the first thing I need to do is multiply both sides by 41. That'll get my denominator to cancel out. And then we aren't working with a fraction anymore, and nobody likes working with fractions. So I have 52.48 is x minus 178. If I add 178 to both sides, I get that x is 230.48, right? So my cholesterol level that marks, let's round that to 230, that marks the 9th percentile is 230. So we used our z-table in this case to work backwards. Let's continue at this normal distribution, right? This one with a mean of 178, standard deviation of 41, and do 3 more little parts. So I want to know what is the percentage of men in this age range that have a cholesterol level of 188 or lower. So 178, 188 or lower. I'm looking for this area, right? And again, that's just going to be our standard z-score. So I find my z-score, which is 188 minus 178 over 41. I get 0.24. So this is my z-score. I take this to my z-table, right? That's going to find the area under this curve, which will also, we can then convert into a percentage to determine what percentage of men have a cholesterol level of 188 or lower. So let's go to our z-table. So I had a z-score of 0.24. So here's 0.2. Here's 0.4. So it's this one right here, this 0.5948. So my z-table would be 0.5948, meaning 59.48%, right? Let me write this up here. 59.48%, right? This area was 0.5948. Next, you can't really see that, but let's go ahead and make some room. What is the percentage of men in this range that have a cholesterol level between 188 and 192? Now, we found for 188, they had an area of 0.5948, and now I want to find this for between 188 and 192. So I'm specifically looking for like this little sliver. So what I'm going to do first is I'm going to find the z-score for 192. And then if I subtract what we found for 188, that should give me the area of this little sliver. So I'm going to take z-score for 198 minus 178 over 41, and I get 0.34. So let's go ahead and take this to our z-table. I get 0.34. I've got 0.34. Of course, I wrote over it, so I can't see it. That gives me 0.6631. So I have a z-table value of 0.6331, right? That's this whole green area here. And then I need to subtract 0.5948. So I'm going to take 0.6331 minus 0.5948, and I get 0.0383. So 3.83% of men have a cholesterol level between 188 and 192. Again, making myself a little room. We'll make this really skinny, normal distribution. The math worked. So next, I want to know what percent of men in this age range have a cholesterol level of 188 or higher. 188 is very popular in this example. So I found that the area of men, that the percentage of men who have a cholesterol level of 188 or lower was 59.48%. So I want to know what percent have a rate higher. Well, friendly reminder and number one key takeaway is that the area under a normal curve is 1, right? And I found that this area was 0.5948. So if I take 1 minus 0.5948, I get 0.4052, right? That is the area right here. So that means 40.52% of men have a cholesterol level of 188 or higher.